A1 alpha 1 plus B1 beta 1, A1 alpha 2, B1 beta 2, A1 alpha 3, B1 beta 3, A2 alpha 1, B2 beta 1, next A2 alpha 2, B2 beta 2, A3 alpha 3, B3 beta 3, right? Next A3 alpha 1, B1 beta 1, A3 alpha 2, B3 beta 2, next A3 alpha 3, B3 beta 3. What is the determinant of this? This is equals to 0, this is equals to 4, this is equals to -1, this is equals to 2. Yesterday I told you the technique, once you don't have an idea, this is like looking like some format. You observe that actually once you go through the elementary row operation, in fact row s row is replaced by s row plus k times of tth row. This is something it is difficult, right? Once you use that fact, once you use elementary row operation, such type of elementary row operation, you cannot get in a simple manner, right? Determinant. So what you do is that applying the product of determinant technique, right? So this can be rewritten as, you need to fix this determinants. So this is actually what I need. I need actually first look at the first element, a1 alpha 1, b1 beta 1. Therefore you need to keep this a1, this is b1, this is alpha 1, beta 1, right? This is 0, this is 0, right? a1 alpha 1, b1 beta 1. Okay, next, what is the next element? What is the next element? a1 alpha 2, b1 beta 2, a1 alpha 2, b1 beta 2, this is 0. Next, what is third element? This is alpha 3, beta 3, 0. Okay, first row elements are fixed. Okay, now look at the second row elements. Look at the second row elements, right? Look at this second row elements. What is this? Already your alpha 1 is there, or beta 1 is there. Alpha 1 and beta 1 is there. What I need is that a2 alpha 1 plus b2 beta 1. Therefore what I keep here, what I keep, a2, this is a2 b2, this is a2 b2
0,
right? So a2 b2, next this element automatically getting, right? a2 alpha 2, b2 beta 2, 0 0. That's okay. Next a2, this is a2, sorry, this is a2.
Question like a2 ఉండాలి sir.
Yeah, a2 alpha 3 plus
B2 also.
b2 beta 3. Okay, next what is this?
A2
a3
A3
b3 0, right? A row in a determinant, at least one row is 0 row. This is 0, right? Once you apply that this technique, you can easily get the answer. That is what actually idea, product of two determinants idea. Okay, and you can go through another example. Suppose this is 2bc minus a square, this is a square, b square, this is c square, this is 2ca minus b square, a square, this is b square, a square, right? 2ab minus c square. Right? So answer is abc bca cab whole square. Answer B, abc bca cab whole power 3. Answer C, abc bca cab whole power 4. It is none. Right? See, you can get this determinant by using simple determinant, because this is 3 by 3. One can easily compute the determinant by using the definition. But instead of doing that, you can apply that product of two determinants. Right? There are so many ways. One way is using elementary row operation to come out with the zeros and ones. That is one way. What is second way? Instead of using row operation, just use this basic definition. Sum of the products of the elements with a row with another with the elements of the cofactors of the same row. Right? That is the determinant of the definition of the determinant. Or else you can use the product of two determinant techniques. Right? Can you say what is this? This is nothing but what I need actually. What I need 2bc minus a square. 2bc, right? So 2bc means what? You need to fix this is c, this is b. Okay, no? 2bc. Is it okay? 2bc. Next minus a square. Minus a square. So this is a. This is minus a. Is it okay? The first element. Is it okay for the first element? bc plus cb. 2bc. A into a minus a square. Is it okay?
Okay, sir.
Next, what is the second element? C square.
B square.
C square. Right?
Okay.
C square. Right? So to get a C square, how can you get C square? Anybody? So you need to fix C here.
C
Right?
fix.
First to fix C. First you fix C. Then think
Remaining
about these
zero.
two elements. Think about two elements. Right? This is nothing but A. You need to fix this
A
B.
B. A
A
B.
minus B. Because I don't get actually C square minus A square AB. What I require is that only C square. So C square plus AB minus AB. Plus AB minus AB means 0. That means C square you are going to get. Next, what I need actually B square. How can I get B square? Yeah, anybody? First we fix B because I need to fix B square, right? B into B. So in first fix B, right? I need actually I want actually only B square. So therefore, so C I don't require. Therefore, what I require here is this is nothing but what?
A minus B.
A
Minus B.
minus C. Right? Next, what I do? This is nothing but so this is an order, right? This is B, C, A, C, A, B. Like this is an order, C, A, B, B, C, A. Therefore, what you get here? This is C, A, B. Just do it. C square plus AB minus AB. Okay, you are getting C square, right? Next, CAC plus AC minus B square. Okay, 2AC minus B square. Next, BC plus A square minus BC. So cancel. Therefore, you are going to get A square. Okay. Next, what is this?
B
BCA,
square.
CAB. Next, ABC.
ABC.
Right? So therefore, actually look at the answer ABC. Determinant starts with the first row ABC, 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 ABC. Therefore, what I do is that interchange the two rows. Second row fixed. Right? Here minus common. Right? Again, minus is there. That means what? This is CAB, BCA, ABC. Right? Therefore, what I fix actually here is nothing but ABC. Again, this is CAB, this is BCA. This is nothing but keep it as it is CAB, BCA, ABC. Again, this is nothing but what? What I require is B. Second row is BCA. Second row is BCA. Look at the answer. Second row is BCA, BCA, BCA. Therefore, what I require is that this is again interchange. BCA, CAB. Here interchange first and third row. ABC. Here minus is there actually. Next, what is this? BCA as it is. Right? Next to CAB. Right? BC, ABC, BCA, CAB. Therefore, this is also interchanging. Therefore, minus is there. Therefore, what you are going to get is that BCA, ABC, CAB whole square. Therefore, what you are going to get is an answer. Right? So this way is very important, useful to compute the determinants. Okay, let us give one more example. 1 plus a square plus a power 4. 1 plus AB plus a square b square. Next 1 plus ac a square c square. Next 1 plus ab plus a square b square. 1 plus b square plus b power 4. Next 1 plus bc b square c square. Next 1 plus ac a square c square. Next 1 plus bc b square c square. Next 1 plus c square c power 4. Right? So to use elementary row operation, it is very difficult, right? It is not in the format actually. Then what is the best trick? Apply product of determinants. Right? So therefore, what you get is actually, I need to have actually what? 1 plus a square plus a power 4. How can you get it? 1, 1. Right? This is a, because I need to get a square, a into a square, a square, a square. 1 into 1, 1, 1 a into a square into a square, a power 4. So first element is fixed. What is the second element? 1 plus ab plus a square b square. So 1, I need to have ab. You are already a is there, therefore you need to fix b. There already a square is there. I need to get actually b square, a square b square. You need to fix b square. Here 1 is there, therefore we're going to fix a with a. Here already, what you're getting is actually I require actually ac. Already a is there. You need to fix c. You need to fix c square. Right? Similarly, what I require here, 1 plus ab. Already a is there. You need to fix b. This is b square. Similarly, 1 c square. So what is this exactly? So these both determinants are same, right? Because this is exactly transpose of the matrix, right? 1, 1, 1, right? A, B, C. Because it's looking like a transpose of the matrix. This determinant, right? Yes or no? A square, B square, C square. This is 1, 1, 1. A, B, C, A square, B square, C square. Because this is exactly, once you take the transpose, you're going to get this matrix, right? Determinant of A transpose equals to determinant of A, right? Once you transpose it, you can get this determinant. So these both are same. These both are same. Therefore, 1, 1, A, B, C, A square, B square, C square, this whole square. So this is what actually answers. Right? Is it clear? Right. Next is, suppose next concept, singular matrix. What is singular? You start with a square matrix. A singular matrix. Before knowledge, data equals to 0. Right? Suppose it is this matrix example. Right? Is it singular? Yes, because data is nothing but AD minus BC. Nothing but 0. So data is 0 means it is singular. Right? So next is this is very important concept. I'm going to give an example which are in CSIR. So non-singular. Non-singular means you start with a square matrix.
Not equals to 0.
0. Non-zero, right? Non-singular means data should not be 0. Right? You can take an identity matrix. Suppose example is identity matrix A itself. Right? 1, 0, 0, 1. What is data? 1 itself. 1 is non-zero. Therefore, it is non-singular. Right? Yeah. Next example. Suppose A and B are example. This is an example. Suppose A and B are non-singular. So obviously, non-singular means once they are non-singular, obviously this product also non-singular. Why? Because once it is non-singular, det A is non-zero. Again, det B is non-zero. Right? What is the definition of det A B? Det A into det B. Det A non-zero, det B non-zero means what? Product is non-zero. Therefore, AB is non-singular. AB is non-singular. right? Similarly, once you go for the converse, once this det AB is non-zero because AB is non-singular. What is det AB? Det A into det B is non-zero. Product of non-zero is non-zero means what? Both of them is non-zero. This is non-zero. Therefore, A and B are non-singular. Means if you take any finite product of non-singular is always non-singular. That is important, right? Suppose you take a second example. If AB is singular, right? Which of the following is true? First one, A singular or B singular? B is A must be non-singular. Right? B must be non-singular. Right? D, A and B both must be non-singular. Anybody?
Both
What is the-
must be non-singular, sir.
A and B non-singular.
Must be non-singular.
How can you get it? You are given what you are given actually. A into B is singular. You are given that A into B is singular. Right? A into B singular means what? Det
Sir,
AB.
first option.
Yeah. AB
First
singular
option.
means
A is
what?
big.
AB singular means what? Det AB is 0. What is the definition of det B? Det AB, det A into det B is equals 0. You know, this is scalar, this is scalar. Product of two scalar is 0 if only at least one of them is 0.
Zero.
That means what?
First one.
Either A
First
singular
one, A or B singular.
or B singular. Right? So answer A is true. A must be non-singular and true also not. For example, you can take A equals to 0. Right? A equals to, for example, non-zero. You can take suppose A equals to identity matrix. True also not. Suppose you take identity matrix. B is equals to 0. Right? What is A into B? Anybody? I into 0 is a 0 matrix. AB is 0 matrix means what? AB is singular. But you know, A is non-singular because det A is equals to 1. A is non-singular. So second option is fail. A must be non-singular. So A must be non-singular కదా. మనకు కావాల్సింది ఏంది A0 తీసుకోండి. You need to take 0. ఈ ఆప్షన్ తీసుకోకండి. You need to take A0 B equals to identity. ఈ కండిషన్ ఫెయిల్ కావాలి కదా. Therefore you need to take A equals to 0 B equals to identity matrix. Therefore what is det A? 0. What is det A? 0. Therefore it is singular. A వచ్చింది సింగులర్ మ్యాట్రిక్స్ వచ్చింది. Therefore this option is fail. సిమిలర్ ఇక్కడ ఏం తీసుకుంటారు? B must be నాన్ సింగులర్ అంట. కావాల్సిన అవసరం లేదు కదా. సిమిలర్ సేమ్ ఏం తీసుకుంటారు? A equals to I B equals to 0 తీసుకోండి. అప్పుడు AB ఏమైతే 0 అయితే AB నాన్ సింగులరే కానీ B సింగులర్ కాదు, నాన్ సింగులర్ కాదు. ఇది కూడా సేమే. సో therefore fail. Is it clear? Right? Next, suppose if A is a square matrix of order 37, then det of A minus A transpose whole power 2011 is equals to answer A 0, answer B 1, answer C 2, answer D 3. Yeah, anybody?
A is a singular matrix, sir. A is
It
a
is
square
matrix of order 37.
A minus A transpose.
Anybody? Any clue? Any clue? Right? Suppose you can take C. You can take this as some, B. already I told you, whenever you are given a square matrix, A minus A transpose is always Q symmetric. What is B transpose? B transpose is nothing but this is A transpose minus A transpose whole transpose is nothing but A transpose minus A. That means minus of B. That means B is Q symmetric. Q symmetric of order 37 means det B is 0 because odd order. 37 is odd, therefore det B is 0. Det B 0 means what? What is B?
0.
Det of A minus A transpose is 0. That means, product of, this is 0. Therefore, what is this actually? Det of A minus A transpose whole power 2011. That means det of A minus A transpose, A minus A transpose, A minus A transpose up to 2011 times. That means det of AB is equals to det of A into det of B. Right? 2011 times. This is 0. So 0 in something is 0. Right? So that is this 0. Is it clear? Idea of the problem?
Sir, of order 37 and sir.
Order 37.
And, A power 37 is equal to I, yes, sir.
A power? A power కాదండి. A power 37. అర్థం కాలేదు నాకు. A power 37 ఆర్డర్ అంటే దీని ఆర్డర్. A is a matrix of order 37. 37 cross 37. A is a matrix of
Okay.
order 37.
37 by 37.
Yeah. 37, 37, right? Right? Is it clear? Right. Next is, let us start with the, let us go with the simple definition, invertible matrix, which is also important. Invertible matrix. Again, it is you start with a square matrix, so repeat left. A is invertible if and only there exists a square matrix such that AB into BA is equals to I. In this case, one can say that B is a, A is invertible. In this case, one can write B equals to, what is the inverse of A? B. What is the inverse of A? B. So B is simply denoted by A inverse. Right? So A is invertible matrix. In this case, A is invertible. Right? Or else, in కొన్ని బుక్లలో లెటర్ రాస్తారంటే A is invertible, A is, left inverse, A is to have left inverse. ఇదంతా యాక్చువల్లీ అవసరం లేదు. Left inverse. If or no left inverse B, if or no B into A is equals to I. Right inverse, right B, if and only if A into B is equals to I. Right? If A has left inverse as well as right inverse, then we can say that A is invertible. But అదంతా అవసరం లేదు. ఒక్కోసారి right inverse ఉన్నా left inverse ఉన్నా అది invertible అవుతుంది. Right? There is actually strong theorem in, Hoffman-Kunze. Go back to Hoffman-Kunze. Once a matrix, if a matrix has left inverse, అంటే ఇది general matrix. Understand? General matrix. You take any matrix as left inverse or right inverse, automatically that is invertible using the theorem, using elementary row operation and system of linear equations in Hoffman-Kunze. Refer it. While I'm going to teach a system of linear equation, I'll tell you this concept. So this is very, very important. Actually, రెండు ఉండాల్సిన అవసరం లేదు, ఒకటి ఉంటే చాలు అంటే నేను అంటున్నా. మీరు తప్పంటారా దీన్ని? రెండు ఉండాల్సిన అవసరం లేదు, ఒకటి ఉంటే చాలు, ఒకటే ఇంకోటి రైట్ అవుతుంది ఆటోమేటిక్. Right? So this is very, very important idea. Right? Suppose you can have a invertible means, so this is important. A is invertible means automatically det A is non-zero. This is very, very important. Right? Invertible means what? What is invertible? A into B equals to I. That means there exists at least one matrix A into B equals to I. Right now, what you do is that take determinant on both sides. So this is det A into det B is equals to 1. What is determinant of I? Det of I 1. So therefore, this is non-zero. Right side is non-zero means what? Left side is non-zero. Right? So therefore, det A is non-zero, det B non-zero. That means what? Det A non-zero means what? We have done it. We have done it. Is it right or not? Similarly, one can do the right procedure also when I deal with the adjoint of a matrix. Right? So this is actually if and only once you go through the adjoint of a matrix, we'll see later. Adjoint of a matrix. So this is also true. Right? Det A is non-zero means once you take this condition, you know, A into adjoint of A is equals to adjoint of A into A is equals to, det A into I. I'll tell you this formula later. So therefore, as det A is non-zero, we can divide them by the equation by det A. What you get is this is adjoint of A by det A is equals to adjoint of A by det A. Why? Because this is non-zero. We can divide them. Is an identity matrix. So A into B, B into A equals to identity matrix. Therefore, A inverse is equals to adjoint of A divided by det A. Therefore, what you observe is A is invertible if and only if det A is non-zero. So this is very, very important. Right? So now I'm going to solve which are in the CSR examination. Right? Right? So problem number 1. Suppose you can take this. Sir, invertible A is always square matrix or any matrix? Hello? Hello?
A is square matrix or any matrix, sir?
A is?
A is invertible if and only if det A not equal to 0 kada, sir. In that case, A is always square matrix or any matrix.
మనం స్క్వేర్ ఇన్వర్టబుల్ దేనికి మాట్లాడతామండి? ఇక్కడ ఏమని చెప్పాను? స్క్వేర్ మ్యాట్రిక్స్ కే పాసిబుల్. ఇన్వర్టబుల్ దేనికి మాట్లాడతాం? స్క్వేర్ మ్యాట్రిక్సెస్. వేరే మ్యాట్రిక్స్ ఇన్వర్టబుల్ ఉండదు కదా. ఇప్పుడు రెక్టాంగిల్ మ్యాట్రిక్స్ స్క్వేర్ మాట్లాడడం కదా. Is it right? Okay. This is true for, see, we define the invertibility for only square matrix. For only square matrix. Right? Okay. So this question asked in CSR. Suppose take this is equals to B into A cube plus 5A square plus 7A plus 19I is equals to I, identity matrix. Then which of the following is true? First one, B is non-singular. A is non-singular. C is, A may be non-singular. D is, A may be singular. Yeah. Yeah, tell me. What is idea? Yeah, any idea? You are given B into A cube plus 5 into A square plus 7 into A plus 99 equals to I. Now what I do is that take both sides determinant. Because I want to check singular, non-singular. Whenever, what is the definition of singular? Determinant is non-zero means non-singular. Therefore, what you do is that take both sides determinant. Det of AB is equals to det A into det B. Det of I is equals to 1. Right side is non-zero means what? Left side should be non-zero. This is non-zero. This is non-zero.
A and B both are correct.
Right? No. What about this? Only B is non-singular. B is non-singular. This is what actually det of a cube plus 5a square plus 7a plus
7a.
19a. This is non-singular. A may not be non-singular. We don't say actually a is singular or non-singular. Information is not given. Right? We are getting only B is non-singular. Understand? Information is not given about a cube. A. Right?
Okay.
Information is not sufficient. Therefore, what is answer?
B is non-singular.
B is non-singular. So this question asking CSIR. Right? Similarly, suppose A is non-singular, A and B are non-singular. Obviously, A plus B. Is it non-singular or singular? So generally, we need not be non-singular. Why? Because if you take an identity A equals to identity matrix, B equals to identity matrix, therefore det A is equals to 1, det B equals to 1. Right? So both are non-singular. But what about this? A plus B? So in this case, it actually you're going to get 2i actually. In this case, if det of AP is equals to actually what? 4, which is also non-singular. Right? It's non-singular. But once you take A equals to I, B equals to minus I, det A is equals to actually what? 1. Det B is equals to what? 1. Both are non-singular. But what is A plus B? I minus I. This is 0. Therefore, det of A plus B is 0. Therefore, A plus B is singular. So in this case, A is A plus B is non-singular. In this case, A plus B is singular. Therefore, need not be non-singular. Right? So this is very, very important. Sum of two non-singular may not be non-singular. Next example, if you take K is any scalar, A is non-singular. Right? What about Ka? Is it singular or non-singular? Anybody? Need not be non-singular. Suppose you take K equals to 0. A is an identity matrix. Right? What is K into A? Anybody? 0 into identity matrix. 0 matrix. Right? This is 0 matrix. Right? It is singular matrix. 0 matrix is a singular matrix. So right, there is a choice singular. Similarly, if you take K is non-zero, right? A is non-singular. That means det A is non-zero. Right? Det A non-zero means what? A is invertible. That means A into A is equals to identity matrix. Yes or no? Now what I do is that you multiply with A and A 1 by K on both sides. Right? Right? Right, you need to take this side here, not like this. You need to take like this. Ka 1 by K into A inverse is equals to identity, because A is invertible, therefore A into A inverse is equals to 1. What I do is that, as you know that K is non-zero, if K is non-zero, therefore this is meaningful, this equation is meaningful, right? Therefore, what you observe is this can be rewritten as, this can be rewritten as Ka whole inverse, right? So therefore, this, what is this? K into Ka whole inverse is equals to identity matrix. That means what? This is invertible. This is invertible. Therefore, in general may not be invertible, but the thing is when you take the K is non-zero scalar, when you take K is non-zero scalar, K into A always non-singular matrix. Whenever A is non-singular, K into A is non-singular, provided K is non-zero. Otherwise may not be non-singular. That is important fact. Right, using this relation, so CSIR, this is a problem in CSIR 2014. If A and B, A comma B and LA plus MB, where L and M are integers, are invertible, then what I get is first option, which of the following is true? L into B inverse, M into A inverse is invertible, is non-singular. Answer B. L into B inverse, M into A inverse is singular. Answer C. L into B inverse, M into A inverse is invertible. Answer D. None of the four. Now tell me. So what you are given is A, B, and LA plus MB. All are invertible. All are invertible. Invertible means what? Sorry. I told you, right? Det A is non-zero.
Det A, det B are not.
All are non-zero. Means A inverse exists, B inverse exists, right? This also det A non-zero. That means what? We can talk about A inverse is meaningful, B inverse is meaningful, LA plus MB is whole inverse also meaningful. This exists. All of them exist. Now, what are options? First, look at options. LA, B inverse, LB inverse plus MA inverse is non-singular. LB inverse plus MA inverse is singular. And LB inverse plus MA inverse is invertible. That means answer in terms of linear combination of integral multiples, right? With A inverse, B inverse. Now what I do is that this is what actually you are given. LA plus MB is invertible. Now what I do, you know one thing, already I told you, A invertible, B invertible. If they are invertible, product of invertible is invertible. I told you this technique just now. So product of invertible invert, this is actually if and only. So therefore, once this is invertible, A inverse into this also invertible, A inverse into this also invertible. Similarly, once this is invertible, this into B inverse also invertible. Yes or no? Is it right? See, A is invertible. A is invertible means B is invertible means A into B is invertible. Similarly, here LA plus MB is invertible means A inverse into this is invertible because A inverse invertible, this is invertible. Therefore, product is invertible. Similarly, this is invertible. Therefore, this product is invertible. Therefore, what is this? Matrix multiplication is distribute over, addition. Therefore, this can be written as L into A inverse into A B inverse plus M into A inverse B inverse is invertible. Right? That means L into B inverse plus M into A inverse is invertible. Right? So L into B inverse, this is invertible. Means it is non-singular. Means invertible means this is option is right. Invertible means, if and only det is non-zero. Invertible means det is non-zero. Once det is non-zero, it is non-singular. Is it clear? So is it clear, all of you? Hello? Is it clear?
Okay,
Hello?
okay, sir. Okay, sir. Sir, first option కూడా correct తీసుకోవచ్చు కదా sir?
First option?
Hello. First one is also right.
Right. Non-singular because determinant is non-zero, right?
Okay, sir.
Because invertible means non-singular. It is non-zero.
Sir, the L comma M belongs to Z, sir. L comma M, both are integers. You take L M is equal to 0.
Yeah, L is equal to 0.
M is equal to 0.
Provided actually what you're given, what is the condition? This is invertible.
LG plus M.
Okay.
LA
L0
MB
L0 M0
plus
పెడితే
MB
0 invertible.
invertible.
Okay.
సో ఫెయిల్ అయిపోతుంది కదా, కండిషన్ ట్రూ అయ్యేటప్పుడు తీసుకోండి. ఓకే, ఇన్ఫాక్ట్ L square plus M square is non-zero. That means L and M should not zero simultaneously. Next, this is also a question asked in CSIR. Right? If A plus B is invertible, then which of the following is true? Answer A plus B whole power 100 is invertible. Answer B, A plus B whole inverse is invertible. Next, answer C, A plus B whole power 2022 is invertible. Next, answer D. A plus B whole power 101 is invertible. Yeah. Which one is true?
Second option, B.
B only. You know, A plus B is invertible. I told you product of invertible is invertible. Therefore, A plus B into A plus B also invertible. Right? So that means A plus B whole square is invertible. So by induction, A plus B whole power 100 also invertible.
All are invertible, sir.
Yeah, that's it. So this is invertible. 101 is invertible. This is invertible. And inverse of invertible is invertible. So all options are true. So such a simple question asked in CSA.
Nilpotent అయితే సార్.
Yeah.
Nilpotent.
Nilpotent గురించి ఇక్కడ ఏమీ ఇయలే కదా క్వశ్చన్. Nilpotent ఇచ్చాడా?
కానీ చాయిస్ ఉంటే.
Yeah, invertible means actually what that is non-zero. Actually this is non-zero. Zero matrix అయితే కాదు ఇది. A plus B whole power 100 అయితే జీరో కాదు. అదైతే షూర్. ఓకే. దీని ముందు కూడా జీరో అయితే దీని ముందు పవర్ కూడా జీరో అవుతుందని నేను అనుకోవట్లేదు. ఎందుకంటే ఈ ముందు పవర్ ఇదైతే జీరో కాదు షూర్. జీరో అయితే ఇన్వర్టబుల్ కాదు. దీని ముందు పవర్ కూడా జీరో కాదు. ఎందుకంటే వన్స్ ఇది జీరో అయింది అనుకోండి ప్రాబ్లం వచ్చేస్తుంది. సింగులారిటీ నాన్ సింగులారిటీ ప్రాబ్లమ్స్, ఇన్వర్టబుల్ ప్రాబ్లమ్స్. సో దీని ముందు అయితే జీరో కాదు. అంటే ఏంటి ఇవి నిల్పోట్ అయ్యే ఛాన్స్ లేవు ఈ మ్యాట్రిసెస్. అంతేనా?
అదే నిల్పోటెంట్ అయ్యే ఛాయిస్ ఉందా?
లేదు లేదు లేదు, ఆప్షన్ లేదు. ఇక దీని ముందు లేదు. అంటే ఆ పవర్ 100 వరకు నాకు మనం చూసేది పవర్ 101 తర్వాత ఏమైతే మనకు తెలియదు. అండర్స్టాండ్? 101 తర్వాత కూడా ఆటోమేటిక్ నాన్ జీరో కదా. ఇదైతే నిల్పోటెంట్ కాదు. ఇది సిమిలర్, ఇది కూడా నిల్పోటెంట్ కాదు. ఇది కూడా నిల్పోటెంట్ కాదు. ఎందుకంటే వన్స్ ఒక్క దగ్గర జీరో అయింది అనుకోండి, ప్రోడక్ట్ ఆఫ్ ఇన్వర్టబుల్ ప్రాబ్లం వచ్చేస్తుంది. ప్రోడక్ట్ ఆఫ్ ఇన్వర్టబుల్ ఇస్ ఆల్వేస్ ఇన్వర్టబుల్ కదా. ఎక్కడ ఏ పవర్ దగ్గర కూడా ఇది జీరో కాదు. అండర్స్టాండ్? ఇన్ పర్టికులర్ దిస్ ఇస్ నాన్ జీరో ఫర్ ఎవ్రీ ఎన్. ఎక్కడొక్క జీరో అయింది అనుకోండి ఏమైంది, ఫర్ సమ్వేర్ ఇట్ ఇస్ జీరో. సపోజ్ సమ్ కే ఈజ్ జీరో అయింది అనుకోండి, అప్పుడు ఏమైంది ఆటోమేటిక్గా సింగులర్ అవుతుంది, సింగులర్ మ్యాట్రిక్స్ అవుతుంది. సో ప్రాబ్లం వచ్చేస్తుంది. కాబట్టి ఎక్కడ కూడా జీరో కాదన్నమాట. రైట్? ఓకే, గుడ్ క్వశ్చన్. రైట్, ఓకే. నెక్స్ట్ ఇస్ దిస్ క్వశ్చన్ asked in CSR again. So such an important topic, matrices. మీకు ఎవ్రీ క్వశ్చన్ పేపర్ తీసుకోండి, 2-3 క్వశ్చన్స్ పక్కా ఉంటాయి ఓన్లీ మ్యాట్రిసెస్. ఇంకా ఐగన్ వాల్యూ, ఐగన్ వెక్టర్ అవి తీసుకుంటే ఇంకా 70 మామూలుగా సగం పేపర్ అదే ఉంటుంది కదా. కాబట్టి చాలా ఇంపార్టెంట్. ఇన్వర్టబుల్ అండ్ వేర్ ఏబి బిఏ ఈక్వల్స్ టు 0, దెన్ విచ్ ఆఫ్ ద ఫాలోయింగ్ ఇస్ ట్రూ? Answer A minus B is invertible. Answer B, A plus B whole power n is equals to A minus B whole power n, where n is even integer. Next, answer C, A plus B whole power n is invertible. Answer D, none. Step none. First, what you are given, just you need to focus on it. A, B, A plus B, these are invertible. Not only they are invertible, A and B commutative, in fact they are zero. And AB and BA zero, in fact they are commutative. Once your matrices are commutative, binomial theorem is applicable. I told you, right? So question, first look at the first option, A minus B, is it invertible or yes or no? Means you're given A plus B is invertible, therefore what is A plus B whole square? AB BA commutative, that means what? Binomial theorem is applicable, therefore this is usual binomial application. This is nothing but A square plus 2AB plus B square. This is 0, right? A square plus B square. Okay, therefore again what you this, A plus B whole power 3, what you're going to get? A cube plus 3A square B
plus B cube
plus 3AB square plus B cube. You know what you observe, what you're given is a plus b is invertible. You know, a plus b is invertible means what? Product of invertible is invertible. This is invertible, right? Similarly, this is invertible, right? By induction, a plus b whole power n is invertible for every n. Therefore, this option is true. Okay, first option is true, right? Next, what is a minus b whole square? Anybody? Usual, because they are commutative. Therefore,
A
square
square minus B square.
a square minus
A square
2ab plus b square.
A
And
square
you know
plus
that
B
this is
square.
0. Therefore, a square plus b square.
B square.
So what you observe, this is what equation 1, this is what equation 2. What you observe? A minus b
Both
whole
are
square is equals to,
A minus B is
Both are
also
equal.
invertible.
both are equal, right? You know, right side is invertible, we have seen. We have seen just now. This is true for every n. Right side is invertible means what? Left side is invertible. Yes or no? Therefore, a minus b whole square is invertible. Once a minus b is invertible, a minus b whole square is invertible. Of course, each individual is invertible. Just now I told you. Therefore, a minus b is invertible. Is it right? A minus b is invertible. And you know what you observe is, you know, this whenever n is even integer, a plus b whole power n is equals to a minus b whole power n, because all the terms a b are 0. You know, a minus b whole square is equals to a minus b whole square is equals to a plus b whole square. Similarly, a minus b whole power 4 is equals to a plus b whole power 4. Therefore, what you observe? Therefore, this you know, all are same. This all are same. Is it clear? Is it clear? This argument also true. Is it right? Hello?
Okay, sir.
Okay. Because
Okay,
a
sir.
minus b whole square is equals to a plus b whole square. Similarly, a minus b whole power 4 is equals to a plus b whole power 4. Because a minus ab equals to b equals to 0 na. All middle terms are 0. A square b, a square, ab square, ab cube, a cube b, all are 0. Therefore, what survives? A power 4. See, what about a cube plus b cube? Anybody? Are they equal? Anybody? You know, are they equal? A plus b whole cube, a minus b whole cube. Are they equal? Even
No, sir.
okay, even problem undadu. Yeah, think equal either. Anybody?
No, sir.
No, right? Why? Because this you are going to get a cube plus b cube you are getting. What is this? This is a cube minus b cube you are getting. So this both are in general may not same. May not same in general. But they are same if you take 2b cube equals to 0. That means b cube equals to 0. That means your matrix with the index is 0. Your B matrix with index is 0. Understand? Your B matrix with index is 0. ఈ కేసులో మాత్రమే ఈ రెండు సేమ్ అయిపోతాయి. జింజేడేలో మాత్రం సేమ్ కావు. Therefore ఆడ్ ఆర్డర్ కు సేమ్ కావాల్సిన అవసరం లేదు. ఈ రిజల్ట్ అనేది ఆడ్ ఆర్డర్ కు సేమ్ కావాల్సిన అవసరం లేదు. ఆడ్ ఆర్డర్ కి ఎప్పుడు సేమ్ అవుతాయి? ఆ బి మ్యాట్రిక్స్ అనేది నిల్పోటెంట్ మ్యాట్రిక్స్. నిల్పోటెంట్ మ్యాట్రిక్స్ అయినప్పుడు మాత్రమే ట్రూ అవుతాయి. ఇస్ ఇట్ క్లియర్? Is it clear?
ఓకే సార్.
Okay, sir.
ఓకే. యా, ఇదే ప్రాబ్లం మళ్ళీ చేంజ్ చేసి ఇచ్చాడు 2015 లో, రైట్? ఇదే ప్రాబ్లం, రైట్? సేమ్ క్వశ్చన్స్ రిపీట్ చేసి ఇచ్చాడు. therefore if a comma b and a plus b are invertible, then which of the following is true? A inverse plus b inverse is invertible. Answer B, A inverse plus 2b inverse is invertible. Answer C, A minus b is invertible. Answer D, A square minus b square is invertible. Yeah, tell me. So what you're given? A, B, A plus b, all are invertible. Right? Therefore, we can talk about A inverse, B inverse, and A plus b whole means. Yeah, what is the guess?
ఏబి సార్.
A,
ఏ అండ్ బి.
A and B. You know what is A? Just go through it. You know, multiply A inverse and left side. Pre-multiply this A plus B with A inverse. Post multiply A plus B with the B inverse. You know, this is also invertible because this is invertible, this is invertible, this is invertible. So product of three invertible matrices is always invertible. Again, matrix multiplication is distributed over addition. Therefore, this can be written as A inverse A, B inverse, A inverse B, B inverse. Right? Therefore, what you are getting? Anybody? This is nothing but B inverse. This is nothing but A inverse. Therefore, this is invertible. Because left side is invertible means right side is invertible. Therefore, this is invertible. Now, what is this? Is it invertible? A inverse plus 2 B inverse.
Invertible,
it-
sir.
Invertible.
Yes, sir.
Suppose I can take A inverse is equals to 2 minus 2i. A inverse is equals to minus 2i. B inverse is equals to I. Right? Yes or no? What is this? What is this? What is A actually? Anybody? What is A?
A is invertible matrix.
A inverse whole inverse is equals to minus 2i whole inverse. That means A is equals to minus 1 by 2 I inverse. That means minus 1 by 2 I. You know, it is always invertible because I it is invertible. Therefore, 1 by 2 is non-zero. Therefore, the scalar multiplication is always invertible. Similarly, what is B? B is nothing but I. This is also invertible. What is A plus B? A plus B is nothing but I minus, you know, I minus I by 2 plus I. That means I by 2. This is also invertible. So conditions, all conditions are satisfied. All conditions are satisfied. Right? A is invertible, B is invertible, A plus B is invertible. The thing is it true actually? What is A inverse? Which I take actually? Minus 2i. What is B inverse? A inverse plus 2B inverse is equals to 2 minus 2i plus 2 into I. That means 2i minus 2i 0. Therefore, it is a zero matrix. It's singular matrix. Therefore, it is non-singular. It's singular matrix. It is not invertible. So this option is failed. Is it clear? Is it clear?
Okay, sir.
Now, what is option C? What is option C?
Not invertible.
General need not be invertible. Suppose you can take this A equals to I, B equals to I. You know, A is invertible, B is invertible. Okay. What is A plus B? 2i. 2i also invertible. So all conditions are satisfied. Now look at A minus B. What is A minus B? I minus I.
0.
0. Therefore, it's a singular matrix. Therefore, not invertible. Therefore, this option is failed. Similarly, same idea. You take A equals to I, B equals to I. A plus B is invertible. What about A square minus B square? I square minus I square, 0. Therefore, this is a singular matrix. It's not invertible. So, general, what are options? Only option A. This question asked in CSR. Right? Similarly, same question which is repeated. The student question paper lo, most of the questions are repeated. A, B, right? Or you know, or matrices such that AB, BA equals to 0. Just ఇంతకుముందు చెప్పాను ఈ ప్రాబ్లం మళ్ళీ అడిగారు ఇదే క్వశ్చన్ చేసేయాలి రైట్ అండ్ A plus B is invertible. Which of the following is true? Option A, A minus B is invertible. Option B, A power 5 plus B power 5 is invertible. Option C, A square plus B square is invertible. Option D, A cube minus B cube is invertible. Yeah, tell me. You are given. See, ఎప్పుడైనా ఇట్లాంటి ఈక్వేషన్ ఇచ్చినప్పుడు కమ్యూటేటివ్ కంపల్సరీ అవుతుందమ్మా చూసుకోండి మీరు కమ్యూటేటివ్ లేకపోతే బైనామియల్ థీరం అప్లికేషన్ నీడ్ నాట్ బి అన్నమాట. What is AB, BA? You know, 0. You know, they are commutative. In fact, they are 0 matrices. Right? What you are given extra? Extra is A plus B is invertible. So binomial theorem is applicable. Therefore, A plus B whole square, just now we have seen A plus B whole square is equals to a square plus b square. Similarly, a minus b whole square is equals to a square minus b square. Therefore, a square plus b square. Therefore, these two are equal, right? So right side equal means what? Left side equal, right? So therefore, what you observe? As you know that a plus b is invertible, therefore a plus b whole square also invertible, because product of invertible is invertible. Therefore, this left side is invertible, means this is invertible means right side is invertible. Once right side is invertible, a minus b whole square is invertible means this is a minus b into a minus b is invertible. That means each individual term is invertible. That means a minus b is invertible. Right? A minus b is invertible. Therefore, first option is right. First option is right. Similarly, what is a power 5 plus b power 5? Anybody? A
Sir,
power
all
5 plus.
right, yes, sir.
Uh,
All options are right, yes, sir.
yeah, check. First option check చేశాను. What is a power 5 plus b power 5? నేను ఆప్షన్ చూడలేదు యాక్చువల్గా. A power 5 plus b power 5. ఏమైంది?
Yep. A plus b whole power 5.
Yeah, good. A plus b whole power 5. Again, binomial application. 5c1, right? A power 4 b, right? 5c2, a power 3 b square, 5c3 a square b cube, 5c4 a power 1 a power 4, next to b power 5. You know, all are 0 because this can be rewritten as ab. These terms contains ab terms. So these are 0. These are 0 because ab equals to 0 now. ab equals to 0. It's 0. So what you're getting? A power 5 plus b power 5. So left side is invertible. We have seen. Means right side is invertible. So this answer also right. What about a square plus b square? Just now at binomial application, this a square plus b square also invertible. What about a cube minus b cube? Anybody?
A minus
A minus b whole cube.
Yeah, a, as you know that a minus b is invertible. A minus b invertible means what? A minus b whole cube is invertible. Yes or no? Once a minus b is invertible, a minus b whole cube is invertible. Therefore, this is same as saying that a cube minus b cube is invertible. Why? Because ab b equals to 0. ఇక్కడ జీరో లేదు కనుక మిస్ అయింది అనుకోండి, ఇక్కడ చెప్పరాదిగా. ఇక్కడ జీరో కనుక తీసేసింది అనుకోండి, ఫర్ ఎగ్జాంపుల్ ఈ ప్రాబ్లంలో చెప్పరాదిగా, కంక్లూషన్ చెప్పరాదు. ఓన్లీ ఏ స్క్వేర్ ప్లస్ బి స్క్వేర్ చెప్పొస్తుంది. ఆన్సర్ ఏమని పెట్టాలి మీరు? యాక్చువల్లీ ఏమని పెట్టాలి? ఇక్కడ ఇది కూడా పెట్టరాదు, ఈ ఆప్షన్ కూడా పెట్టరాదు, ఈ ఆప్షన్ కూడా పెట్టరాదు. సో ఇన్కంక్లూషన్ అన్నమాట, రైట్? సఫిషియంట్ కండిషన్ ఉండదు. ఓన్లీ ఏబి బిఏ ఈక్వల్స్ టు బిఏ ఇచ్చినంత మాత్రాన, రైట్? ఏబి బిఏ ఈక్వల్స్ ఇచ్చినంత మాత్రాన ఫస్ట్ ఆప్షన్ చెప్పొస్తుందమ్మా? చెప్పరాదు. బికాస్ ఫస్ట్ ఆప్షన్ ఎట్లా చెప్పారు? బికాస్ ఏబి ఈజ్ ఈక్వల్స్ టు బిఏ ఈక్వల్స్ టు 0 అయింది కాబట్టి రెండు సేమ్ అయినాయి కాబట్టి చెప్పగలను. జనరల్ గా 0 తీసేసినాం అనుకోండి చెప్పరాదు. అండర్స్టాండ్? సో దట్ ఈస్ ఇంపార్టెంట్. ఏ ఆప్షన్ కూడా చెప్పరాదు. 0 మిస్ అయింది అనుకోండి, ఏ ఆప్షన్ కూడా చెప్పరాదు. సో 0 ఈజ్ వెరీ వెరీ ఇంపార్టెంట్ కదా. సో దట్ ఈస్ ఇంపార్టెంట్, రైట్? నెక్స్ట్ మళ్ళీ ఇదే క్వశ్చన్ సిఎస్ఐఆర్ లో సేమ్ మోడల్. A, B are invertible. Which of the following is true? First one, A inverse is invertible. Second one, B inverse is invertible. Third one, A plus B is invertible. Fourth one, A inverse plus B inverse is invertible. చెప్పండి అమ్మా. What is your guess?
A, B, C, A, B, D, sir.
A, B, D,
D. Yeah,
A
ఇందాక
invertible
explain.
కదా. A invertible, B invertible కదా. A invertible, you are given actually A invertible, B invertible. Inverse of invert is always invertible. So they are invertible. Right? Therefore, this answer right, this answer right. Right? Once A is invertible, A into A inverse into A is equal to 1. That means you take A inverse on both sides. I inverse is I. Therefore, A inverse, A inverse whole inverse is 9. Therefore, A inverse is invertible. Similarly, B inverse is invertible. Now, what about A plus B? Anybody? Need not be right, because you can take A equals to I, B equals to minus I. You know, it is invertible, it is invertible. What about A plus B? Zero matrix. It's a singular matrix, not invertible. So this option failed. What about this? I can take A inverse is I. I can take B inverse is minus I. What is A inverse? What is A actually? A is nothing but A inverse whole inverse. I inverse. What is A? I inverse is I. What is B inverse? What is B inverse whole inverse? Minus I whole inverse. That means B is equals to minus 1 I. That means minus I. Therefore, you know that actually it is invertible because identity matrix. Minus I also invertible. It is invertible. What about A plus B? What about A inverse plus B inverse? I have taken actually A inverse is I, B inverse is minus I. Therefore, I minus I. Therefore, 0. It is singular. Therefore, not invertible. It's also okay. Is it right? Is it okay?
అది బంద్ చేసి పాయింట్ వేసి దాన్ని బంద్ చేసి
Right. Next. Next question. Suppose we take this. Let A is a matrix of order. In fact, you can take a real matrix of 5 cross 6. B is a matrix of order, 6 cross 5. Then which of the following is true? First option, det of 4AB is equals to, you can write proper. Det of AB is equals to 4 power 5 det AB. Option B is equals to 4 det of BA is equals to 4 power 6 det BA. Option C, 4 det of AB is equals to 4 power 5 det A det B. Option C is equals to 4 det BA is equals to 4 power 6 det B det A. Tell me. You know, A is a matrix 5 by 5 cross 6. B is a matrix 6 cross 5. You know what is AB matrix order? AB matrix order is this
5 by
5 by 5. Similarly, what is BA matrix?
6 by 6.
6 by 6. Is it okay? Okay. Right. Therefore, AB matrix has 5 rows. BA matrix has 6 rows, 6 columns. I told you one technique. Det of Ka is equals to K power n into det A. Whenever A is a matrix of order n by n. This is a very famous technique. Right? And very famous technique, det of AB is equals to det of A det into det of B. You know this. Now you go through the options. Det of 4AB is nothing but, det of K into AB is nothing but 4 power. What is AB order? Order of the
5
matrix
by
is 5.
5.
So 4 power 5 into det AB. Yes or no? Because det of K is equals to K power n into det A. Therefore, det of K into AB is equals to 4 power 5 into det AB. So this answer is right. Right? Now, this can be rewritten as det of AB is equals to det A into det B. Therefore, this answer also right. Similarly, 4 into det BA is equals to, what is the order of BA? Order of BA is 6 by 6. Therefore, 4 power 6 det BA. So this answer is right. This can be written as 4 power 6 det B into det A. Therefore, this answer is also right. Therefore, 4 answers are right. Is it clear? Is it clear, all of you?
Okay, sir.
Next is, suppose A, B, n by n matrix, whose each element.
Sir?
Yeah.
Sir, above problem lo A and B square matrix above కదా sir, 5 by 6, 6 by 4. Individual.
Hello. A
Sir.
by AB. Yeah, AB.
AB are not square matrix, no sir.
Yeah. Yeah,
Then-
good question.
Sir,
Yeah,
then
good, very good. Who said?
Swapna.
Swapna, very good. Actually, these options are not possible. Good, very good. These options are not possible because we can talk about only that for only square matrices. This option is not possible. Good, very good. These options are not possible. Only this and these two are possible. Very good. Because det A is meaningful for only square matrix, but it is not square matrix. This is not a square matrix. Therefore, det A, det B is not possible for rectangular matrix. Right? It is possible for only det matrix. Is it clear? Very good. Is it clear, Andy?
Okay, sir.
So each element is 1. Then first option, A must be non-singular. B must be a B option. A must be a singular. C must be C option. A must be singular matrix. A may be singular matrix. A may be singular. D. A may not be singular. Yeah, tell me which option is right.
A must be singular.
A must be.
Singular, sir.
Suppose you take n equals to 2. A equals to suppose singular అంటున్నారా? సింగులర్ అంటున్నారా? A equals to ఐడెంటిటీ మ్యాట్రిక్స్ తీసుకున్నాం అనుకోండి. get A equals to 1 is నాన్ సింగులర్ వస్తాయి కదా? అసలు
Each element అన్నా కదా సార్. Each element.
yeah, each element is yeah.
Each element
Okay.
is one.
Sorry. Right. ఏ ఆప్షన్ రైట్ అంటున్నారు మీరు? ఏ ఆప్షన్ రైట్ అంటున్నారు?
Singular, sir. Determinant 0.
ఏ మస్ట్ బి సింగులర్ అంటున్నారా?
అవును సార్.
సపోజ్ ఐ కెన్ టేక్ n equals to 1 స్క్వేర్ మ్యాట్రిక్స్ ఇది తీసుకుంటాను. ఇప్పుడు చెప్పండి డిటర్మినెంట్ ఎంత?
ఓకే సార్.
సో ఫెయిల్ కదా? సో ఇది ఫెయిల్. మస్ట్ బి సింగులర్ అనేది ఫెయిల్. సారీ, ఇది కాదు. ఆప్షన్ ఏంటి? మస్ట్ బి సింగులర్ అనేది ఫెయిల్. ఇది ఫెయిల్. సింగులర్ కావచ్చు కాకపోవచ్చు. అండర్స్టాండ్? ఇదే
2/2 నుంచి అయితే కంపల్సరీ సింగులర్.
2/2 తీసుకుంటే అయితే 1/1 తీసుకుంటే కావాల్సిన అవసరం లేదు. బట్ మస్ట్ బి అనేది ఫాల్స్ అనమాట. రైట్. నెక్స్ట్ ఫస్ట్ ఆప్షన్ మస్ట్ బి నాన్ సింగులర్ అంట. నాన్ సింగులర్ కావాల్సిన అవసరం లేదు కదా. ఇదే ఆన్సర్. రైట్, ఇదే ఆన్సర్. A equals to 1/1 1 A may be singular అంట. సింగులర్ కావచ్చు కదా. కదా. నెక్స్ట్ ఏ మే నాట్ బి సింగులర్ అంట. తప్పు కదా. ఏ మే నాట్ బి సింగులర్ కదా. సింగులర్ కావాల్సిన అవసరం లేదంట. సింగులర్ కావచ్చు కదా. ఇప్పుడే అన్నాం కదా సింగులర్ కావచ్చు అని. రైట్. సో దర్ఫోర్ ఇట్లా క్వశ్చన్స్ ఉంటాయి. రైట్. నెక్స్ట్ ఈస్ ఇంకో క్వశ్చన్ ఉంది. ఇది కూడా యాక్చువల్గా 2014లో ఇచ్చాడు క్వశ్చన్. యా, దిస్ క్వశ్చన్ 2013 సారీ 14 అంటున్నా. 2013లో ఇచ్చాడు ఈ క్వశ్చన్. ESIR. A is equals to Aij. N is bigger than equals to 3n. Right, where each entry is equals to bi square minus bj square for I equals to 1, 2, 3 n, j equals to 1, 2, 3 n. Right. For some real distinct, this is important, real distinct numbers bi bj. Right. Then what is the det A? Answer A. Product of BA minus BJ. Next answer B. Product of BA plus BJ. Answer C. 0. Answer D 1. Yeah, tell me. The question is 2013 లో CSR 2013. See, n bigger than equals to 3 కాబట్టి you can take actually A is a 3/3 matrix. You can take A is 3/3 matrix. This is A1, A12, A13. I can take n equals to 3. A21, A22, A23, no, A31, A32, A33. What is A? What is A age entry? BA square minus AJ square. You know, both entries are same. That means what? B1 square minus B1 square. B1 square minus B2 square. B1 square minus B3 square. Next B2 square minus B1 square. B2 square minus B2 square. B2 square minus B3 square. Next B3 square minus B1 square. B3 square minus B2 square. Next B3 square minus B3 square. What is this? What is this? 0. B1 square minus B2 square. B1 square minus B3 square. This is B2 square minus B1 square. This is 0. Next B2 square minus B3 square. Next B3 square minus B1 square. B3 square minus B2 square. B3 square minus B2 square. Sorry, this is 0. Tell me. Is there any idea about this? Is there any idea? Is there any idea? You know, all diagonal elements are same. All diagonals are 0, right? And look at this entry, B1 square minus B2 square. Here B2 square minus B1 square. Here B1 square minus B3 square. Here B3 square minus B1 square. Is there any idea?
Skew symmetric.
Yeah, who said skew symmetric? This is skew
Pascal.
symmetric matrix. Skew symmetric matrix of order 3. Right? What is data? 0. What is data? 0. So no. బట్ ఇక్కడ థింగ్ ఏంటంటే ఇక్కడ చూడండి, ఇక్కడ మీరు అబ్జర్వ్ చేస్తే ఈ ఆప్షన్ ఎందుకు ట్రూ కాదు చెప్పండి? అక్కడ ఈ ఆప్షన్ ఎందుకు ట్రూ కాదు చెప్పండి? ఇది కూడా ట్రూ కావచ్చు కదా, బిఐ బీజే 0 కావచ్చు కదా. ఈ ఆప్షన్ కూడా ఎందుకు ట్రూ కాదు? ఇక్కడ బిఐ ఈక్వల్స్ టు బీజే కావచ్చు కదా, ఇక్కడ బిఐ ఈక్వల్స్ టు మైనస్ బీజే కావచ్చు కదా. ఈ కేసులో ఇది 0 అవుతుంది కదా. ఇది ఎట్లయినా ఇది కాదు, ఎందుకంటే 1 ఎట్లయినా కాదు, మనం చూసాం 0 వచ్చింది. ఈ ఆప్షన్ ఎట్లయినా కాదు. ఇది కూడా బిఐ ఈక్వల్స్ టు మైనస్ బీజే కేసులో ఇది 0 అవుతుంది కదా. ఎందుకు కాదంటే ఇవి ఏంటి డిస్టింక్ట్, ఏంటి ఇవన్నీ ఏంటి డిస్టింక్ట్. సో దర్ఫోర్ ఇది 0 అయ్యే ఛాన్సే లేదు. అండర్స్టాండ్? 0 అయ్యే ఛాన్సే లేదు. ఇస్ ఇట్ క్లియర్? కాబట్టి ఆన్సర్ ఏంటి? డిస్టింక్ట్ అనేది ఇంపార్టెంట్ అనమాట. ఇక్కడ డిస్టింక్ట్ అనేది చాలా ఇంపార్టెంట్. ఇక్కడ డిస్టింక్ట్ కనుక తీసేసాం అనుకోండి, అప్పుడు ఆన్సర్ ఇది కూడా రైట్ అవుతుంది. అర్థమవుతుందా? ఛాన్సెస్ ఉంటాయి అనమాట. దర్ మే బి ఛాన్స్. ఇది క్లియర్?
Yes.
Yes. Yeah, with this I conclude. 825 is there. Is there any doubt? So this is invertible problems. ఇంకొక 2-3 ప్రాబ్లమ్స్ ఉన్నాయి కానీ అదే చెప్తానండి. ఇది CSI